Hello and welcome to the Unreal Engine Motion Graphics webinar. My name is Andy Blondin and I have the great pleasure to share with you a new sample project that we've been working on called the Hype Chamber. The Hype Chamber was a collaborative effort between the Unreal Engine product team, Psyonix, Capacity Studios, and ESL Gaming. In 2021, we set out to rebrand the RLCS broadcast with an energetic and modern vibe using the Unreal Engine. With the Hype Chamber concept, we wanted to celebrate the vibrancy of Team Color. We wanted each part of the broadcast to feel unique and customizable. We decided to create an interior showroom that would highlight both the cars and Team Colors, while also highlighting features of the Unreal Engine like ray tracing and global illumination. Our goal was to combine the power of the Unreal Engine with esports and eventually share a sample project with the community to enhance their own broadcasts. Our aim was to make it open, free, and highly customizable to your needs. Today we're going to break down some of the design decisions, rigging, blueprinting, media playback, remote control, and overall best practices we learned from the project. So let's dive into the Hype Chamber project with Jazz from Capacity Studios and explore how to use the Unreal Engine as a motion graphics and broadcasting tool.
Thank you, Andy. Hi, I'm Jasbir Sidhu, one of the art directors at Capacity that worked on this project. Today I'd like to cover the creative design aspects for this project. We'll start with a brief overview and then jump right into the environment and screen design setups. Then we'll discuss how we might systemize some elements for motion design. And at the end, I'll share how we might start to customize the package further. Before we begin, I would like to disclaim that in the following slides, I'll be highlighting specific examples and jumping back and forth interchangeably between the Hype Chamber sample project and the Rocket League Championship Series, which the sample had been based on. But do note that they are very nearly identical in core functionality, and I'll be sure to point out any significant differences. Also, we acknowledge that we started this journey in UE4, and though UE5 became available in the form of early access midway through our development, we opted to remain with 4.27 to not disrupt our development timelines. However, pretty much all of the concepts we'll cover should translate directly for UE5. Now that that's said, let's jump in and start by discussing what this broadcast sample is and give a quick overview of the Hype Chamber. As you can see here, the Hype Chamber is a virtual space with different sections that utilizes a set of curved screens around a central hero object. This space acts as a staging area for showing matchups, highlighting teams, announcing winners, and overall just building hype around the storylines for RLCS action every week. You'll see that we're trying to harness the power of Unreal with real-time ray trace reflections, and overall wanted to inject some energy into the broadcast that is typically only found in live event situations. And we wanted to do that in a way that would be both authentic to the esports communities of RLCS, but also extendable to be built upon for other setups. And before we move on any further into the design aspects, I think it's important to pause here and reflect a little bit on some of the goals we had as we were creating this project. They're pretty straightforward, but just to go over them briefly, one of our first main objectives was to have an artist-friendly design approach, where there are many ways of approaching tasks in UE. We wanted to take the more accessible method for artists wherever possible. Naturally, we also knew we wanted to push broadcast workflows within Unreal. And we were designing this project for the RLCS, but we also had to design it in a way that would be extendable for other completely different scenarios. And our approach to broadcast design here was to support the existing broadcast show by supplying a full suite of high-end primetime assets. And we also needed to make sure we had a versatile way of making content that would be easy to update, especially considering the open tournament format of the RLCS broadcast. And lastly, we were aiming to have a dynamic and reconfigurable stage design so that we can have as many options to create unique and fun content. And just to conclude, I think it's important to understand that these agendas influenced a lot of our decisions and how we chose to solve specific problems. And we wanted to be transparent about these so that you or anyone on your team can feel empowered and confident to dissect the sample project and build your own broadcast setups. Also, to touch on briefly on tech specs, we were targeting a HD broadcast for Twitch at 5994, and we were aiming high by including real-time ray tracing reflections, so the actual broadcast was targeted for a high-end PC with a 3090 graphics card, though the sample project is also optimized to run on lower-end systems as well. Now let's jump into UE and take a quick overview of the project file. I'll be brief here because there's already more content available online in the form of the Inside Unreal video on YouTube that was released alongside the sample project, as well as the official documentation. As I navigate around, you'll see we're in the interior environment with the circular screens. At the top of the outliner is the main blueprint controller, and I'll leave Warren and Patrick to discuss some of the logic behind it later on. But for now, if we toggle to different teams, we'll see it reflected live in the environment. If I click play on the project, we'll see that it defaults to a matchup element, and we can switch to other different elements using the mode select. We can play and pause the animations at any time, or even switch teams while it's running. Some elements, like the text interstitial, also allow us to switch between multiple variations and even type the text live dynamically. Let's exit out of play mode and talk briefly about how we might organize assets within our project. You'll see we have three main folders in this esports sample project. In artist elements, we store all the core and generic assets that are intended to be reused multiple times across different elements. These include everything you might already expect, like the core blueprint, logic assets, environment meshes, materials, as well as media assets and presets. The scene folder is pretty straightforward and contains assets that are tied to a specific element in a broadcast. For example, the Team Victory bump contains the map, sequence, sound file, and blueprints that are required for this element and no other composition. The team elements folder contains, you guessed it, assets that are specific to each individual team, including the textures, logos, and materials. Now let's take a look around and discuss the environment levels and screens. If we look at the levels panel, we'll see that we actually have multiple levels that are loaded in but hidden away. We do this for organization purposes as well as performance reasons. If you look at the lighting, we have a setup for lights when the compositions are focused on the center, and we have a different ones when we have two cars like the matchup. This way we can focus on optimizing the lights for our ray tracing and reuse the same rigs for multiple elements and have a good starting point visually as well as a good starting point performance-wise. Storing assets and levels is also a key way we optimize performance for a real-time broadcast. We want to avoid any additional computation that can bog down the CPU enough to cause frame drops. One of the functions that happens to be expensive performance-wise is spawning multiple new objects simultaneously. Spawning actually includes multiple operations under the hood that can be costly. So by storing all the elements you need in hidden levels, you can just toggle the visibility between multiple elements during a broadcast. If we toggle the level labeled screen content, we'll see all of the visuals on the screens are affected. And that's because we're using a scene capture method to display the visuals. If I switch the layout here to have an additional viewport, and if we take a look beneath the entire scene, about 10,000 Unreal units below, we'll see a different space altogether with a host of different elements being used for the screens. This corresponds directly with what's being viewed above in real time. In this screen content space, we are positioning specific cameras known as scene capture cameras that take what's below here and renders what it sees directly to a texture. This texture can then be fed into various materials on the screens above. This is kind of amazing because you can create content in a new way and have some real fun here, which we'll go over in a bit. It's important to be mindful of the performance impact of scene captures and generally try to limit the number of cameras, the resolution, and turning off different render features that you don't need. This scene capture system is the primary way in which we create motion graphics in an intuitive way in this project. It's an alternative from using UMG that does require some scripting and is more catered towards UI in games. Let's chat about how we bring motion graphics to life through animation next. And for that, let's hop into the matchup sequence. The sequencer is the primary method to create the compositions and animate various elements. All the assets are grouped and being possessed from different levels simultaneously. By adding a level visibility track, we can help dictate which level should be visible and which should be hidden. In this matchup, we have the dual car set up with the lighting, and even the tunnel environment as the camera spins around. Here we can see that this matchup animation contains quite a few different elements. In the intro, we have footage that's being played out onto a plane. We have stacked text being used as a transition device. We have colored plane meshes that swoop in from the sides with animated chevron textures on them. And we have the text for verses, as well as scrolling marquee. And we also have animated shapes going on, all the while being fully dynamic. It's a simple composition overall. Already we can see with these set of elements, there's a lot of complexity that can emerge if we factor in all the variation throughout the project. This is where Unreal becomes really handy and especially shines, because aside from just like real-time rendering, we can approach design systematically. We're going to cover some of the visual aspects and how you might start to think of them when you're creating your own broadcast project. First, we need a way of storing information about all the variants required for the team's branding, logos, card skins, and more. And for that, we use data table assets. Using data table assets, we're able to define a structure to store whatever information we want as rows and columns. I also want to remind that there's already a deeper dive into exactly how this is being rigged in the Inside Unreal video on YouTube. And again, Warren and Patrick will discuss more aspects about the logic later on. To keep things simple, whenever a new team is selected using the controller, the blueprint just retrieves this information and slots them neatly into all the right places. Now let's see how this might relate to motion graphic elements, beginning with color. Each team has its own set of colors, and beyond that, even the broadcast itself might have alternate themes for a show. In order to apply the colors stored in the data table on surfaces as materials, we use the help of a special type of asset called Material Parameter Collections, or MPCs. MPCs can store a collection of vector data as color, and it's especially handy because both blueprints and materials are able to interact with it. The blueprint retrieves the color information from the data table, stores what it finds in this MPC, which can then be used to affect multiple masters and material instances globally. To integrate this aspect more efficiently, we use the help of a material function, which can be stored and reused multiple times across different materials, but all pointing towards the same MPC asset. We use a simple logic gate and expose these checkboxes as parameters, and once implemented in a material, we have the ability to dictate if this is meant to be a dynamic material, and if so, which option of the team color it should retrieve. When all that is handled correctly, you can have color systemized across virtually anything. Here's a fun example from the RLCS broadcast of a dynamic Niagara fireworks system that takes place for a victory graphic. It's worth being strategic about how many colors need to be dynamic and avoid excessive options. In this sample project, we utilize a simple strategy where we have two main color palettes. The primary is intended to showcase a team at their best using their core colors, and we have slots for the background and accent colors. We also have a secondary palette to account for instances where we might see multiple teams within a composition and need to compromise for legibility. It also acts as a away theme. Text is another major component in broadcast graphics, which typically incorporate quite a lot of text. In this project, we used the 3D text actor tool to create most of the text you see throughout, even though we were displaying them as flat shapes for our aesthetic. This worked out great because it's already an existing tool in the engine and has tons of options for controlling the look with outlines, block spacing, even tracking with options even for per character animation. Already built into the tool is the functionality to limit the size of the text based on the number of characters and the space available. This is awesome because it's one of the typically most frustrating parts of broadcast graphics. Combining this tool with smart use of material effects and animation in the sequencer, we can also yield quite a wide array of animation styles. It's important to note that not all text in the project is using the 3D text actor tool. In fact, if we take a look at the scrolling marquees that are present throughout, you'll see that they're just a panning texture on a plane. The textures are prepared externally and when brought in can be assembled into their own material instances and slotted right into the team's information in the data table. Even using this more basic approach, UE brought great benefit because an issue we ran was that each texture could be a different length depending on the number of characters. But since we have a fixed way we are using the marquees, we can detect the image resolution and automatically calculate the amount of tiling directly within the material itself and not have to worry about manually entering values for each variant. Let's talk about how we use different shapes and patterns. There's quite a wide variety of approaches here because Unreal is such a versatile tool. You can get a lot of mileage by just being really intentional with your designs. A simple panning texture can go a long way to make a surface become alive. Another method is to prepare animation externally and bring them in as Alembic files. Unreal has really improved a lot of the functionality and stability in regards to Alembic, and overall this method makes it a really artist-friendly approach. This is the method we use to create some of the core hexagon stripe animations you see throughout the project. We had constructed this in C4D, but you can use any DCC software you're comfortable with. Once you get more familiar with Unreal, you can really start pushing things and have even more fun as an artist. This version of the hex animation is just a material on a plane and utilizes procedural techniques and animation. If you're coming from the motion graphic world, you can sometimes almost think of a material as a comp in After Effects, with lots of possibilities to layer on effects and pre-comps to perform further tasks. Here, the core concept was to create a hexagon shape and a gradient emanating from the center. We multiplied the value by a lot and used a frac node that creates this repeating pattern. Then we just used a method to clip it to be black and white, and after some additional controls, we feed it into the material as a mask, and voila. I'd also encourage taking a peek at this more muted background stripe effect for another fun example. Within a broadcast, you may sometimes want to include content prepared externally as footage. There are different ways we configure the project to apply different content to the screens. The default method uses the real-time scene capture method, which you could use if you would like to combine footage with other elements in UV, such as in this open. Alternatively, there are already toggles built in to feed in static images and video directly onto the surface of the screen. Just adjust the materials and feed in the appropriate texture. Footage requires a couple of assets and steps, namely an image media source to import image sequences, a media player asset for Unreal to be able to interpret the source as footage, and a media texture asset that allows you to output the footage from the media player as a texture to be used in materials. From there, it's a matter of applying the video material to your geometry, in this case a 16:9 plane, and then creating a new media track within the sequencer and filling it with the correct link properties. We recommend using uncompressed image sequences for smoother playback and to ensure better frame sync accuracy. Now that we've covered some motion design elements, let's customize the project a little by adding a new team design. And for that, it can be as simple as preparing your visual assets and connecting it to the project's existing logic. Let's go over the logic part first. We'll need to update two key assets: an enumerator, a fancy way of calling basically a named list, so we can select our team, and the data table asset itself, which we've already peeked at. You can find the assets in the Blueprints folder in Artist Elements, and it's as simple as adding a new row to the enum with our try code. We can also add the full name if we want to see the text when we hover our mouse over the list. Then we pop open the data table and do the same by adding a new row and making sure that the first column corresponds directly with the try code we had entered earlier. And that's it for the core logic part. If we toggle to that team, we see the name on hover and a whole bunch of debug colors when we select it. Next, we need to feed the art assets to the data table. Here's a quick overview of assets I've already imported into the project. The easiest way to start is by duplicating an existing team's material. Then we can just feed in the right texture we want and load in any settings. I'll speed up the next section so you won't have to watch me do this over and over again. Then, once that's completed, we can open up the data table again and take a look at the new row we created earlier. We now have to link all the textures and design the color system we want to use. Choosing colors can actually be a fun part, but to be brief, I've already pre-selected some values. We'll speed things up again as I attach materials we just created. Once that's done, we can hit save and minimize the data table, and take a look at the main controller to select our team. Things are looking pretty good, but I've left out the custom mesh. Let's do that next. We'll want to navigate to the core blueprints folder and duplicate the existing Jaeger so that they're based on the same child blueprint class. This system makes it easy to continually add new mesh variants and helps a ton in the RLCS project where we have new core sponsors frequently. We'll select the new core mesh we added and make a few modifications first. We use blueprints and not static meshes directly, so we can have additional options to customize, such as by adding lights. We'll save this asset and open up the data table again to update the core actor. Then we'll hit save. By toggling Team B, we can refresh the controller and see that our car is, in fact, working. And we're essentially done for a basic new team setup. Let's pop open the sequence to confirm that everything's looking good. And after a quick refresh and hitting play, we can see that everything's working as it should. This is a basic setup, but there's also a ton more you can do with the project. I highly encourage playing with the project and taking a look at the online documentation for more on what you can do. We've covered quite a few aspects from the visual side, and I've been brief on touching on the functionality. So I'll pass things over to Warren next, who can really speak to the technical design. Thanks for listening.
Hello again, everyone. Now that you're a bit more familiar with the project structure and some of the artistic systems we use, let's take a deeper dive into some of the advanced blueprinting that binds it all together. Hopefully, you've already had a chance to download and dissect the sample project, but if you haven't already, it'll be helpful to know the Hype Chamber controller blueprint you see here on screen acts as the central hub of functionality and control in the project. The concept of a control blueprint is fairly common in all types of projects, including games and virtual sets. By inspecting this controller, you'll hopefully discover some useful techniques for modifying this project or creating your own. I'll go ahead and open this blueprint to briefly talk through some of the key concepts we used. And if it seems a bit overwhelming, don't worry too much. I'll do a simplified demo shortly after to demonstrate how to create some of this functionality from scratch. Okay guys, so now that we have the blueprint open, I'm just going to kind of start at the top and work my way down, calling out a few key pieces of functionality and concepts I think you'll find useful. I'll actually start here at the event tick because that paints a pretty clear picture of what's going on with the project as a whole. So just following the execution flow, I'll just summarize what some of these functions are doing here. You can see here that we have a set track-o function. What this is really doing is just saying, what is my team A and team B selections currently at the moment? Then we have this update designs, and this pretty much just checks with the data table for the design elements associated with that team before going to apply designs here, which just applies those variables to elements in the scene. This is what makes it look how it does. You see here when I switch teams, we can see that reflected in the scene as a whole. And then after that, we have a check mode, and this is pretty much just asking which graphic or animation do we want to target at the moment. Following this, the second flow here, you can see we have update advanced, and this just sets elements like the post-processing sample bounces and applies the background screen element. So this just allows it to update the scrolling text and the logo you see here in the background. From there, I'm just going to skip on down to this data table section, which I will cover in the short demo. You can see we talked about the update design function before. And what it's really doing here is it's checking the data table for whichever team I have selected here. And then it reads all those variables that is stored in the data table and their values, and then temporarily stores them here in the controller. So you can kind of look through this project on your own, but you'll see that's generally what it's doing. It does this for team A and team B. And then I'll scroll all the way down here to the core of what's going on here. And this is the apply designs function. And you can see it pretty much just goes through and sets those variables that I said were temporarily stored here. We tried to comment and color it to make it a little bit easier here. You won't see a lot of nested functionality here. We wanted it fairly easy for a newcomer to jump into this project and kind of see what's going on. So you can see that I update the team colors. The spotlight is going in the scene. We update the car's skin. So that's the materials and liveries you see on those cars that Jazz mentioned. And then we have things like the 3D logos that flow over the cars, the scrolling marquee text, and the logos in the background. So that's the general feel of everything. There's a few other things that you might find useful. This might include this mode switcher I mentioned before. If I was to go into this check mode function you see here and open it up, you'll see what it is just a collection of select nodes with several sequences assigned to different enum slots. So this just allows you to say, all right, what is my general animation that I want? And if I do have this text animation selected, go within that and check to see which text animation I have selected, and it does the same for backgrounds. And that's generally all we're doing here. Okay, I'll jump right into demoing now, just to kind of illustrate the idea of what you can do with a control blueprint and how to work with data tables. In order to make this example as simple as possible, I'm actually going to close out this blueprint and open up another map that I've already prepared. This is car room map. And you can see here it's a simple map. I haven't done anything too crazy yet. It just has some basic lighting and geometry for the wall. The only included assets are the 3D logo geometry blueprint here. You can see if I click this, it'll swap it out. That has built-in functionality already. And I have the Jaeger car asset that's included with the project. What I'm going to be doing is hot swapping this material slot right here to different car paint options and showing you how to do that dynamically, as well as activating the functionality that I just demonstrated for the 3D logo that's already included in the project, and that's to swap these out to different assets that you might have already previously prepared and isolated blueprints. All right, so let's put these back at default. And this one back at default as well. And get right into it. The first thing we'll need to do in order to communicate with both these standalone blueprints in a central location is create our own blueprint controller. For that, I'm going to go to my folder here, my developers folder, and start making some assets. The first prerequisite being a new blueprint class, and I'll just make this, it doesn't matter what class type, but I'll make it an empty actor, and let's call it demo controller. All right, I'm just going to throw this right in the scene immediately so it can start affecting elements in the level. And from this, I'm just going to open it up. And let's just try to make this a bit more visible. I actually don't need to place any components or add any pieces of geometry. All I care about is holding the information for these two assets here that I want to control. The first asset being of this BP logo type. I know I'll need a variable for it, so I'll just go ahead and make one of those. Let's just call it my logo, and I'll change the variable type here to BP logo. You can see I'll grab it right here, this object reference. I'll make this editable so I can see it in the level, and I'll leave this in the default category for now. So I'll compile this. And immediately after doing that, if I click the demo controller, I should already see a slot for it, and I can see my available options there. So I'm gonna select BP logo. I'll do the same thing for the Jaeger now. I'll make a variable for it since I know I'll care about it later. My car. I'll expose that, and I'll swap it to be BP car Jaeger. These are child classes here, so I could select the space one, but for now, to keep it simple, I'll use the Jaeger object reference, and I'll click compile on that, and you can see it's already shown up over there, and I'll select the Jaeger and the scene. So now that we have the controller in the scene and references to both the assets that we're going to want to control, I want to get together some of the prerequisites for working with a data table on that. So the first thing we'll need for a data table is actually a structure asset, and you can find this under the blueprint section when you right click and create a new asset. So I'll do that, and I'll call this ST for structure and do demo. I'm going to pop that open, and I'll start adding the variable types that I want to store and later apply. So first, I know that I will want to change this logo base class here from this drop down. So I'll actually make a class reference. Actually, I need to figure out what kind of class I want to use here. Sorry about that. So if I actually open this blueprint and look for that variable that I'm actually controlling here, my logo class, I actually can get a little cheat code preview here, and it looks like what I care about is BP logo base. That's my class type that I have selected there. So let's do BP logo base. I see it here, and I want to get this class reference, and this will be my logo selection here. And the second thing I care about is the material that's on this piece of geometry here. So I just double click that asset so I can grab the car mesh here, And I care about this element 0 here. And this is a material instance type. So I'll make another variable and call it my car skin selection. And let's look for material instance. And for this one, I just need an object reference here. I can go through and set some defaults. So let's just do what we have already in the scene. So logo base is already the first option. And I'll click the magnifying glass here to target this asset in the content browser and select it here. So that way I have some good defaults. Once you've completed this step, you can actually save and close this asset. So I'm going to close out this structure. And I'll click this asset again here and go right click this and browse to, or press Control B just to get me back to this workspace that I'm using right now. And the next thing I'll need is to start with a data table. So now with the controller open, the first thing I want to do is find a way to access the selections that we stored in that data table we just created. So in order to do that, I'll actually create a new function or custom event. I'll do a custom event in this case by right clicking here and looking for a custom event and selecting that. And I'll call this one get data. From that, I'll drag off and I'll search for data table. And you can see if context sensitive is checked at the very bottom, there's a get data table row. That's what we want. And once I have this node, it'll ask what data table asset reference do I want to use, and I want to use the DT demo that we just created. Once selected, this row name field here will automatically populate with options of the rows that we named in that data table. So I'll leave it at 1 by default, but actually I'll drag off of this because this is what we'll use to select which theme we want to use and apply in the scene. So actually I'll drag off and promote this to a new variable and call this theme select. And since this will be used for controlling it, I'll actually make this editable to the scene and compile. And we now want those two pieces of data, the material and the selection of which logo we're going to be using available. So I can do that by dragging off the out row from that from the data table and selecting break here, or I can do the same thing by right clicking on this node and selecting split. So this will show all the fields that were available there. Since I know I want to store these variables somewhere so I can look at them from the controller before applying them to the scene, I'll go ahead and do the same thing I did to the row name and promote these to variables that'll be here in the blueprint. So I'll actually promote this logo selection and I'll promote it here. And let's call it logo selection. And I'll do the same to car skin, promote it and call it car skin selection. And I'll wire both these up if I can click them. And I'll also make sure these are both exposed right here, instance and editable and exposed. So I'll compile this and save it. And I'll close it out so we can just see it in action in the scene really quickly. Actually, I'll reopen this controller really quickly. We forgot to actually call this function somewhere so we can actually get feedback. And I'll do that by just calling this get data function in the construction script graph. So I'll actually do get data. And I'll click compile and save. And this time we should be good. And I immediately see over here on the right the new theme selection option and the feedback of what logo class selection and skin we have associated with that row. So I'll test this by typing in some of the other row names we know, like 2, and I see that's updated, and I'll do the same thing for 3, and that seems to be updating correctly. So now that I see it updating correctly here, I want to apply these options to the scene. So I'll move them to the defaults quickly. I'll open the controller again before making a couple new functions to apply these selections to the scene. Okay, so with the controller open again, I actually want to go back to the event graph. And just below the get data custom event, I'll create a new one, custom event. And I'll call this one apply data because that's exactly what I want to do. From this, we'll need references to both the logo and car, which we already created. So first I'll drag in the logo reference I have here. And just for best practices, I'll do a is valid. And this pretty much just checks to make sure that this reference is a valid reference and exists in the scene. So you can do that. Or what I like to do is I like to right click on this node here and do a convert to validated get. And this pretty much does the same thing, but it's a bit cleaner in the flow for me. So once I know that I do have a valid reference to the logo asset, I'll look and see what exactly it is on this this asset that I want to change. So clicking the BP logo in the scene, I see on the right side what I want to change is this my logo class option here. So I'll look for that by compiling first and then dragging from the my logo reference and looking for my logo. And I see it's already populating at the bottom. What I want to do is set this variable. So I'll set the my logo class. Like this here. And I want to set it to the option that I have stored here that I pulled from the data table. So I'll drag this right into that. And that's pretty much it for the logo. The only thing I'll do to ensure that it updates is call a custom function on it called update logo. And this just ensures that it works while in editor mode. So I'll do that. I'll make this a button that you can see in the editor as well by clicking on this custom function and selecting call an editor. All right, and now we're pretty much wrapped here. But I also want to do this for the car. So I'll actually drag between these two nodes here and do a sequence node. And this just allows you to keep things a bit cleaner for when you want to do multiple flows. So I'll drag from the second option and actually I'll grab the car reference. And I'll do the same thing I did previously and convert it to a validated get and connect those just to make sure I have a valid reference to the car, the Jaeger in the scene. And if I select in the scene and double click this asset here, I'll know that it's this SM car mesh component on it that I actually want to get the element index 0 slot for and update. So I'll look for that. I'll drag from the my car. I'll compile first just to make sure the reference is valid. And I'll look for SM car and I see it here. So once I have the car, I actually want to set the material on it. And I see that node here. So I'll click that one and I'll connect these. And I already know the material selection I want to use is the one that I have stored here from the data table. So that's all it kind of takes. We just want to make sure that this function is being called. So I'll go to the construction script and after the get data, I'll do a apply data. So I'll compile and save this. And let's check in the scene to see what we have going on. So I'll click the demo controller again, and you can see I have this apply data function. I hopefully shouldn't need to select that since I attached it in the construction script. And let's change some of these options here. So I'll select option 2, and I can see that it's updating, and I'll do option 3. So what we just demonstrated here is pretty much the gist of what's happening in the main scene of the sample project, but we just did it with one set of assets instead of 2 sets of assets where you would have a team A and team B. So hopefully you found this helpful, and now I'll move back into the main scene to cover a few other key concepts. Okay, so back here in the main level, I actually wanted to touch on one more thing I think would be useful to a lot of people, and that's the idea of batch rendering these animations that we've provided in the sample, or using the logic to create your own batch rendering system. So you can see here under the esports sample folder, under artistic elements, under blueprints, if you look for this editor utility widget, versioning utility. So I have this here. I'll just right click and select run editor utility widget to fire it off. And you'll see it'll pop open this window where a user can select a type of graphic similar to how they can do on the Blueprint controller. And they can select which teams are involved with that graphic in a full list. So I could make a matchup that involves Team SGA versus Team CRN, and do a second matchup that involves the Unreal Racing League versus Unreal Racing League B. So you can actually try this on your own, but what I really wanted to focus on was the scripting behind it and how you can use it. So the first thing you'll need in order to integrate with the Movie Render Queue subsystem on your own will be to make sure the scripting plugin is enabled. So I'm going to go to Edit Plugins. And if you search here for scripting, there's this sequencer scripting plugin. And this just pretty much allows access to the movie render subsystem and Blueprint, as well as some Python scripting functionality. So just make sure you have that on. Once you have that on, if you create your own editor utility widget, you can go here, editor utility, and create your own editor utility widget. For now, I'm just going to talk through the one that we already created. So I'm going to just double click that. And it pretty much in appearance looks exactly like a UMG widget. So I won't cover the appearance side. I'll just jump right into the graph. And it looks like a lot, but it's actually quite simple. So starting at the top, we have pre-construct, and this pretty much just applies the visual elements to the options we have here in the scene. In the design view, and set to our default options that you can see kind of on the left side here. So these options. But if you look below, you'll notice that it's just one button function event here that just runs the batch renderer. So let's take a look at what run batch renderer actually does. So in simplest terms, it pretty much just creates a job count list here from how many options a user adds to these arrays. And that's how it knows how many jobs it's going to need to create in MRQ. And it does just that. It creates a job for each one. So moving down, we have this update queue index. And this pretty much just means that once it finishes rendering off one job, it knows to move to the next job by looking through this array and seeing where we are. The create job function is actually what uses the sequencer scripting plugin I showed you a bit ago. And that just allows it to access the MRQ subsystem and get the queue and do a lot of configuration here. So I have it use the target sequence that you select here from the graphic dropdown, and it creates a new job based off of that. And while creating a job, you get all the options you would as if you went to cinematics and opened the MRQ option yourself. So this includes everything from the name of the job, the configuration, which is the render preset we have here. It looks into the world to make sure we have the correct map associated with that render sequence, the author, and just moving to the right here, there's a little bit of Blueprint scripting here to just make sure that the output name of the file updates based on what your options are. After that, it simply runs the actual executor class, which actually starts the movie render queue renderer. And once it's done, it has one binding check at the end just to make sure that the jobs are actually finished, and it clears out the queue. And this just makes it so that if I had the movie render queue open, those jobs that are dynamically created here are cleared out. So that way, when I go to render again, I don't re-render the same exact jobs. So with that, we're actually going to wrap up this demo here. I hope you found something useful in this. And I'm going to pass it over to Patrick Wombold, who's going to go into more detail on the production concerns with this project, including video input and output. So thank you for your time.
Okay, now I'm going to talk a little bit about the media capture and SDI output process that we use for this project. When we use this project in production, we're using Blackmagic 8K Pro output cards, and thus we ship the sample with these assets included. If you have a Blackmagic 8K Pro card, this should just work out of the box. However, for this demo, I don't have that same card, and I'm going to show how to set this up using a media profile instead of using an output asset. In order to do this, the first thing we're going to have to do is create the media profile. So if I go up to the top here and select New Empty Media Profile, I'll get this window to pick a media profile class. Once I select that, it's going to ask where I want to save it. I'm going to stick it in my developer folder. I'm going to call it local media output. Once I do that, I'm going to get a pop-up that tells me that the project doesn't have any proxies configured. The way the media profile works is we have these proxy assets that point back to it. So in order to do this, I could do all this manually, but I'm just going to go with the auto configurator. And it's going to ask me, where do I want to put these proxies? So I'll leave it in the default location. I'm going to put one source and one output. And I don't need any bundles since I'm not actually dealing with any inputs in this project. Once I hit configure, the media profile has been created and the proxy assets have been placed. So if I look in my developer folder, I'll see the media profile. And then inside media and proxies, you can see the proxy assets that we have here. So now what I'm going to do is open up the media profile and configure it to actually match the configuration I have here at home. So here at home, I have a small monitor that I'm running with the SDI output on SDI 3. So I'm going to go ahead and pick that. So if I go AJA, I'm going to go fill, single link 3, 5994. And here on the end, I'm using external Genlock input. So I'm going to pick external for my reference. Then I need to actually tell it what I'm doing for the Genlock. So if I click this, go to SDI input, I'm actually using the breakout cable on the reference pin, and then I need to supply it an output configuration as well. Once I do this, I should be good to go on the media output. However, there's something handy that I can do. It shows me up here, I can get back to it pretty easily, and it shows me which one I'm using. But if I don't want to have to keep picking this every time, I could go into my project settings, media profile, and from here I can pick the media profile so that it chooses this one by default every time I start up the project. Now that we have all those things configured, we can double check that our settings look right. In order to actually check the Genlock timing, if I go to Window, Developer, and go down here to Time Data Monitor, I can get a look at what's happening here. I can see I have my AJA custom time step set to 5994, and then I also have my timecode provider if I was using one. Right now I'm not using anything, so it's just showing the default engine one. Then what I want to do is when I'm using this project in play mode, I'm actually going to need to replace this spot here. So if I go to the BP Hype Chamber controller, the media output, I need to pick the proxy asset here. This proxy asset points back to the media profile and tells it what configuration to use. However, these controls actually only work once you're in play mode, as that's how it was designed. These functions don't actually call when we're in editor. So if I wanted to just get a preview of what I'm doing inside the editor, I need to use the media capture window. So if I go to Window, Developer Tools, Media Capture, I have this panel here. I can pick either render targets, a specific viewport, or in this case, I'm just going to use the current viewport. Same thing, I need to pick where it goes, so I'm going to use the proxy asset. And once I do that, I can hit the capture button, and then on the monitor to my left, I can see that I'm getting proper SDI output. If I want to use the project the way that we did in production, once I go into play, if I then select this, I can use the enable or disable buttons to enable or disable SDI. These settings also work with the web remote. So if you're using the web remote to run this project, they'll also work for that. And that's how you set everything up with a media profile. Hopefully this is helpful, and we'll move on to the next topic. And now I'd like to talk a little bit about the performance requirements for this project. When we started this project, we were targeting 1920 by 1080 and a frame rate of 5994. In order to maintain the quality that we'd become accustomed to, as well as keep the frame rate high, we had to use a variety of techniques to kind of isolate the areas that we wanted to use ray tracing for and then not use it in other areas. So by default, ray tracing is enabled in the project, but we're really not using it for all of the features that it's possible. To dive into this a little bit, I'll look inside the post-process material that's responsible for most of these settings. And we can see that ray tracing has been disabled for GI, and also we're not using it for translucency. The main effect that we were going for with the ray tracing was we wanted to have it so that we got this nice reflection on the floor with it. If you have a semi-rough material that you're using, a planar reflection really isn't going to get the job done. And in many cases, screen space was leaving us with too many artifacts as we just had too many different angles to consider when we were designing this project. So in order to kind of give people some control and a little bit of kind of latitude on this, we actually exposed some of these controls to the BP Hype Chamber controller so they could be adjusted in real time. I believe by default, these are turned down to the absolute minimum, which is like 1 sample per pixel, 1 bounce. We have the roughness set here at 0.45. There's not a whole lot of surfaces where you would need multiple bounces, so this setting didn't really give us too much of an advantage. However, the sample per pixel is really where you get the most bang for the buck, and that's the one that has the most cost. If I turn this up to something like 16, you can see how much it smooths out the noise and the reflections. However, this has a really high GPU cost, so we always kind of have to balance that against what we want the scene to look like. Knowing that we also have the ability to render this scene out, we wanted to make sure this was easily exposed so that we could make changes to this and kick off a render, and we'd be able to get a nice higher quality look when we're rendering these things out. Something else that we had to consider was with the lighting. We really didn't want to spend too much cost on lighting. However, since it's an indoor scene, we can't get away with just using one directional light, so there's a lot of smaller lights that are doing various things. Especially when we're lighting cars and things like this with a lot of reflective surfaces. Many of the lights will actually be these kind of rect lights that are we're using them to cast these nice kind of streaks and things on it. You can see when we turn them on and off what they're actually doing. However, not all of these things need to cast shadows, and for the majority of them, we're not using ray tracing shadows. In fact, I think there's only one light that actually has ray tracing shadows enabled, and this was simply to give this nice little outline on the ground where the car was. We wanted to make sure that was nice and sharp. But other than that, we tried to bake everything that we could. Everything that's in the background, everything that isn't changing, those lights are marked static, and for the most part, we just tried to see what we could bake. I think the only ones that are left that aren't baked are the ones that are actually inside these fans, as that would just cause some really weird looking artifacts to try and bake that while the fans were moving. So if we do a quick GPU profile, we can kind of quickly just dissect what is happening in the scene. So the first thing is the scene capture. What the scene capture is actually handling is all the text and things that are in the background. It's actually being done beneath the scene, and then we're capturing it and projecting it onto the wall surface. So that's what this scene capture is for. Then if we dive in more, there's several parts of this that are responsible for the lighting. One is the shadow depths. Then we have the actual direct and indirect lighting with shadowed and non-shadowed. The big one, of course, is the ray tracing reflections, and then there's denoising that goes with it. Then we have a fairly light post-processing that's happening. All of these gave us a pretty good GPU time that we felt like we could get away with, and we didn't have to use temporal upsampling. The reason we didn't want to use temporal upsampling in this project is because we thought that someday we might need to run this at 4K. And if we were already upsampling to get to 1080p, then we'd be having to do like a 4x upscale, and that's really not going to give us the quality level we wanted. So we wanted to make sure that this project ran really well at 1920 by 1080. And that's why we, like I said, for the most part, most of these lights, a lot of them don't even cast shadows. And the ones that do, most of them are not using ray tracing. We really wanted to reserve all the ray tracing power we could in order to get these nice ray trace reflections. Feel free to dissect this a little bit and just kind of, again, most of the performance stuff is always around lighting and materials. And so definitely dig into the lighting and the post-process, and you can kind of see some more of what we did. The last thing I'd like to talk about, and probably my favorite topic on this project, is the remote control API. We knew early on in this project that we were not going to control it inside the editor, that we would have some sort of external control mechanism, whether that was a web page or a tablet or some kind of show control software. In order to facilitate this, we made sure on our BP Hype Chamber controller, all the properties that we would need are readily available so we can easily expose them to the remote control API. The plugins for this are the remote control API and the remote control web interface. They're both already enabled on the project, and the first time you run it, likely it's going to install some prerequisites, such as Node.js, which is shown here in the description. Assuming that goes smoothly, inside your project settings, there's some settings such as the port number, and there's also a Boolean to auto start the web server. What this does is it will ensure that anytime you launch the project, the web server will be already running in the background. This is really handy. So now that I already have both of these things working, I'm going to go into play mode. I'll go full screen. And then I'm going to grab the web browser. I'm going to 127.0.0.1.7000 since I'm on the same machine. And then if I pick something, so we'll pick Hypechamber Wide and hit play graphic, it's going to play out that graphic. I can change team names. And then depending on what I pick, some of these other options are become enabled. So if I pick this text option and I type in my awesome text here, play this graphic, I'm going to get the text option. And then if I go to, say, the player name one, then on my player options, I can type in like my player handle and play it out. I'm going to get that. So you can already see how we can have different options depending on which graphic we play, and the web interface is pretty intuitive into how we can lay this stuff out. So I'll go back to this one and just point out a couple other things before we go back to the editor. We've also exposed the enable disable SDI buttons, which we talked about earlier. This will enable the SDI output, assuming that it's configured correctly. And we also have quality settings for our reflections, specifically the ray tracing ones. So we can adjust samples per pixel, depending on, again, what kind of performance constraints that we have. So now let's go back into the editor and I'll show how this works from the remote control preset. So in this particular project, we're only using one remote control preset asset. You can have more than one, but we just thought it'd be easier to make one. If I open it up, we can see here, this is the list of properties that we had exposed, and these match what's on the web page. If I look at the BP Hypechamber controller, we can see anything that has a little eyeball next to it is something that's exposed. So in this case, we have the teams, these text lines. But one thing that doesn't show right away is these buttons. Right, so these are function calls that are specific to the actor. So what I'll do is I'll show how we can expose that over here, and we'll add one of these buttons that we don't have. Right now we have buttons for play and reset, but we don't have one for pause. So I'm going to show how to do this. If we go over here to the remote control panel, and I go over here to expose, I'm looking for an actor function. I'll go and I'll just type in the first part of what I'm looking for, which is the Hypechamber controller, and then I'll add this pause graphic. Now that I have this here, I can go and add this button on the web page so I'll have control of it. So I'm going to go ahead and save this, and then I'm going to go open up the web interface. I'm going to give myself a little more space, so when I click this tab here, it toggles between control mode and design mode. This way you don't accidentally make edits. If it starts on presets, we're going to go over to properties, scroll down, I'm going to find this pause graphic. I'm really just going to drag and drop it over here, and now it's already in the web page. I'm going to just type in a short label here, and now if I click control, we're good to go. I can shrink this back up and we're ready to try it. So if I close the control panel, we'll go into play. And now I can play the graphic and pause it with the button. And I can repeat this procedure for as many different properties as I want to expose. Let's say I wanted to expose some light colors or intensities of things. All this would kind of follow the same logic where I would, on the remote control preset, I would just expose whatever they are. They'll add them over here, and then I can drag and drop them on the web interface. Hopefully this gives you some good ideas as to what you can do with the web remote control, and also just kind of what some of the options are and how they would work when you play with the web interface.
Thank you so much for joining us today. It was our pleasure to be able to break down the project with you. Head on over to the Unreal Engine Marketplace and you can download the sample. You can also reach the sample from the Unreal Engine launcher on the Samples tab. Okay, next up, let's head over to meet the team and do a little bit of questions and answers.